Sana needs to draw the graph of y equals 3 to the power x between 0 and 4. She draws the graph on the grid. Okay, I don't know what else she's done wrong, because she's write down one thing Sana has done wrong. Well, the only thing I can see is this. 3 to the power 0 equals 1. And so this should go through there. And by the way, anything to the power 0 equals 1. Now, prove algebraically that this can be written as this. Okay, so we're going to start off by writing down what that actually is. So 0.123232323. And we're going to call that x equals. Now, we've got to manage to get rid of that 232323. And the way we do that is one of our numbers we're going to make is 10x. So we're going to times that by 10 and we get 1.23232323. Now this is one of those times when you really need to line everything up really well. Now if you did 100x, it would be 12.32323, and if we put that on top of that, it would be a bit useless. So we're going to do 1000x instead. By the way, it does help that 990 divided by 2 is 495. So, and that is going to be 123.232323, etc. Now we're going to take both of those things away, and we get 122 on this side, and we're going to get 990 on this x on that side. And if we divide through by 990, we get 122 over 990. Now, half of 122 is 61. And half of 990 is 495. And that's how you do that. Right, I'm now going to just do this so that I can go on to the next one. Okay, this is some sort of algebraic, it's just algebraic fractions. Now, there's two ways of doing this. There's my preferred way, and there's the preferred way of at least one of my students, which is, so you can times out by, my way of doing it is times out by x plus 4. So I'd start off with 1 plus, that's 3x plus 4 equals x plus 4. Okay, then you can times out by 2 minus 2x. So you get 2 minus 2x, because that's times 1, plus, and I'm going to times that out, 3x plus 12. I'm just going to keep them in brackets because you never know. And that equals x plus 4 times 2 minus 2x. I'm just going to do a quick thing, because eventually you end up doing it this way anyway, so I don't really see the point in doing it another way. Plus 4, 2 minus 2x. So that's 2x plus 8 minus 2x squared minus 8x. And so that equals, let's just check, so it's minus 2x squared minus 8x plus 2x is minus 6x. And then plus 8. And we know that on this side we get 3x minus 2x, which is an x, and 12 plus 2, which is 14. I think that's right. 2 plus 12 is 14, minus 2 plus 3x is that. Okay, now we've got to make one side equal to 0. You know what? I'm going to add this side on so that I get a positive 2x. So I'm going to add minus 2x onto this side, so I get 2x squared. I'm going to add 6x onto that side, so I get plus 7x, because I've got to add that x. I'm going to take off 8, and I get plus 6 equals 0. So now I'm going to times a by c and get 12. And it's got to add to 7 and times to 12, so it's 3 and 4. So I'm going to go 2x squared plus 4x plus 3x plus 6 equals 0. That's just taking the bits in the middle, like literally in this case that bit and that bit, but in this case this bit. And we're going to put 2x outside, we're going to go x plus 2 plus, and then we're going to go 3 and x plus 2 equals 0, and that means that x plus 2 and 2x plus 3 are our answers. So x equals minus 2 and x equals minus 3 over 2. And that is, I think, enough for a minute.